My name is Jake Latham, and I am the team lead this semester. Our team name is Gap Engineering. Our team consists of 5 members. We have Jake Macon, Daniel Cox, Mike Rasmussen, myself, and Wyatt Lance. We each have a passion for engineering, and we have enjoyed working on this project together. We have been working with our external PE, Joy Laprevote of JUB Engineering, Vice Provost Paul Barr is our faculty advisor, and our design professor, Austin Ball. Our project is a pedestrian bridge for the JBS meatpacking plant in Hiram, Utah. They requested an engineering assessment and design for a safe employee crossing from their west parking lot to the second floor of the JBS plant offices. The crossing would go over 1200 West, a road with vehicles commonly exceeding speeds of 40-45 miles an hour. Currently, the employees must use a worn crosswalk in order to cross the street to enter the plant to go to work. We decided on a covered pedestrian bridge with a secure entrance so that only employees would be able to enter the plant and use the bridge. Mike will now introduce the 4 alternatives that we have analyzed to end up at the pedestrian bridge for JBS.
So as part of our engineering assessment, our team developed 4 alternatives that we decided on as alternatives to this crossing. The first of which we thought of was, of course, a pedestrian bridge, which would elevate pedestrian traffic above 1200 West, completely separating them from possibility of being hit by cars or anything else on the road. A pedestrian bridge would be very convenient because it allows direct entrance into the JBS facility, and at the same time keeping pedestrians safe. The second alternative our team developed was a HAWK crossing. HAWK is an acronym that stands for High Intensity Activated Crosswalk. There's a HAWK crossing located on USU's campus near the USU Credit Union that was installed last year. It currently allows pedestrians to cross the road without worrying about having to stop cars, having to let people know that they're crossing. It consists of stoplights and pedestrian signals that are timed to keep pedestrians moving along with vehicles moving. The next alternative our team analyzed was a traffic adjustment. A traffic adjustment would consist of purchasing a segment of 1200 West to prevent traffic from entering near where the crossing is. The approximate location of the closure is shown in red on this figure. A difficulty with this alternative is JBS would need to purchase the segment of 1200 West, which would more than likely be very difficult. However, if the crossing was purchased, or if the segment of the road was purchased, pedestrians would no longer have to worry about traffic entering the roadway at that area. The final alternative our team assessed was a do-nothing alternative. There currently exists a crosswalk near the employee parking lot that pedestrians are currently using to enter the facility. The crosswalk is old and marred by traffic and would require painting and maintenance throughout the years. The do-nothing alternative is the cheapest alternative because it only requires painting of the crosswalk. Each of these alternatives were analyzed in a Pew matrix that our team created, which Jake Macon will now describe.
Thanks, Mike. So as Mike was saying, we went ahead and we evaluated the 4 alternatives that we determined with using a Pew matrix. So we went ahead and we ranked each one of these evaluations according to the Pew matrix, and we did it according to one another. So basically, if we gave one of the projects a 4, all the other ones could not receive a 4, and we ranked them from 1 to 3. There were 6 categories that we went ahead and determined that we would evaluate the alternatives against. The 6 categories are safety, aesthetic, construction time, environmental considerations, convenience, and maintenance. When we were talking to JUB and JBS about the project, they told us that the most important thing for this project would be the safety and convenience of the project. And so we went ahead and weighted those ones the highest. Secondary objectives would be the aesthetic, construction time, and maintenance of the projects, with the least concerning but still applicable category being environmental considerations of the project. So when we go through the list, in the first category, safety, the traffic adjustment was by far the safest of the alternatives, so we went ahead and gave it a 4. The bridge came in second only because with the traffic adjustment there would be no traffic at all, so the pedestrians would be the safest. When it comes to aesthetic, the bridge was by far the best, far outpacing the second place, the hot crossing. In construction time, the do nothing wins because, well, it has 0 construction time, so therefore it is the highest and the fastest, the best. With the stoplight, the hot crossing being the second best. In environmental, do nothing was by far the best option, as it doesn't change anything in the environment, and the environment has already adjusted, with the hot crossing coming in a close second. For convenience, the bridge was by far the most competitive, and it was far ahead of the other options, with the hot crossing coming in second. For maintenance, the do nothing, just because it would be the cheapest and it's already there, so that would by far be the best one, with the traffic adjustment coming in second, just because the road wouldn't have to be as taken care of as much. So after we went ahead and went through all these 6 categories, we gave them their scores and we times them by their weighted average, and their scores were given just to the right on the Pew matrix. And when we scored it together, the best alternative was the bridge with a 2.9 score, which beat out the hot crossing with a score of 2.6. So we'll go ahead and turn the time over to Wyatt Lance, and he'll go over the design considerations we used for the pedestrian bridge.
Thanks, Jake. So as Jake stated, for our alternative analysis, the bridge met all the criteria of JBS. And so as we developed the design of the bridge, we decided that for the bridge itself, that it would be a completely enclosed structure, that we'd have glass walls, a cement floor, and a roof on top to keep, for safety reasons, for the employees walking across, so that they're keep it safe from the elements and from people slipping. Furthermore, the bridge would span 120 feet from the parking lot to the building. It would be elevated above the elevation of the road by 19 feet, and the bridge would have 2 abutments on each side of the bridge, and none on the road to avoid cars hitting the abutment in the road. So the 2 abutments would be a deep foundation and a column. And the deep foundation will be a drilled shaft that would be 28 feet tall, which would span across the weak layer of sand where the bearing capacity is not stable enough to support the bridge. And then the column would connect directly to the drilled shaft. And then and then the bridge would connect to the column. Then for the security building, we would have lighting and electricity and HVAC coming through the bridge into the security building, where the security building would then be completely blocked off from normal people, and only employees would be able to access it with a security card. And as employees are able to access, they would go up to a flight of stairs and cross the bridge, where the bridge would connect into the JBS building. So I'll turn the time over now to Daniel, who will talk about the calculations for the JBS pedestrian bridge and building.
Why, thank you, Wyatt. So for the calculations, we broke our bridge up into two parts. We broke it up into the bridge and the security entrance, as both of these kind of need to be built on two different codes. So the bridge we designed based on the AASHTO code, and the building we built in accordance with the IBC that uses ASCE 716. These codes use live loads, dead loads, wind loads, earthquake loads, and snow loads in order to determine the strength that these buildings need to be. After we broke them up, we used the codes to get the loads that were required for the specific area and our bridge and our structure. We designed both our bridge and the building inside of RISA 3D, which is a professional program that is used all over in the field. We designed them and threw in our loads based on both the codes that we used, and the code said whether it was a viable option or not, and then it would suggest improvements, and then we would run with those improvements and get the most economical structure that we could. We then checked the members by hand to check for viability, and that is how we designed both our bridge and our building. I would like to turn the time over to Jake Latham to discuss the things that we have learned while doing this project.
Thank you, Daniel. As we come to an end, we would like to share some of what we've learned by doing this project together. Our main problem as a group was learning to read the assignment descriptions that we were given. We would have a problem in which we would try and complete our assignments in an expedited way, try and go and get the project done as fast and accurately as possible. But by doing this, we actually ended up doing more work than the assignment called for, and we wouldn't know that until the next assignment, in which we would have already done it. So as well as along those same lines, we learned to stay organized in both our work and our communication. By leaving one person out, it would affect the whole group. So we learned quickly to stay in constant and accurate communication with each other. And along with communication, something that at least I learned during this was I learned to communicate with people that are below our technical understanding, as well as people who are quite a bit above our technical understanding. Trying to keep up with people who know so much more about civil engineering than we do, as well as slowing down and explaining ourselves to those who don't. So to end, I would like to extend our gratitude to Joy Lappervote, Paul Barr, and Austin Ball for a great experience. And we'll go ahead and end here. So we would like to thank you for listening and have a great pandemic.
If you like the video, hit the like button in the bottom and click subscribe. And also 100% would be great.